In mathematics, real algebraic geometry is the study of real algebraic sets, i.e., real number solutions to algebraic equations with real number coefficients, and mappings between them. Semi-algebraic geometry is the study of semi-algebraic sets, i.e., real number solutions to algebraic inequalities with real number coefficients, and mappings between them. The most natural mappings between semi-algebraic sets are semi-algebraic mappings, i.e., mappings whose graphs are semi-algebraic sets. Terminology. Nowadays the words semi-algebraic geometry and real algebraic geometry are used as synonyms, because real algebraic sets cannot be studied seriously without the use of semi-algebraic sets. For example, a projection of a real algebraic set along a coordinate axis need not be a real algebraic set, but it is always a semi-algebraic set. This is the Cauchy-Seidenberg theorem. Related fields are O-minimal theory and real analytic geometry. Examples. Real plane curves are examples of real algebraic sets, and polyhedra are examples of semi-algebraic sets. Real algebraic functions and Nash functions are examples of semi-algebraic mappings. Piecewise polynomial mappings are also semi-algebraic mappings. Computational real algebraic geometry is concerned with the algorithmic aspects of real algebraic geometry. The main algorithm is cylindrical algebraic decomposition. It is used to cut semi-algebraic sets into nice pieces and to compute their projections. Real algebra is the part of algebra which is relevant to real algebraic geometry. It is mostly concerned with the study of ordered fields and ordered rings and their applications to the study of positive polynomials and sums of squares of polynomials. The relation of real algebra to real algebraic geometry is similar to the relation of commutative algebra to complex algebraic geometry. Related fields are the theory of moment problems, convex optimization, the theory of quadratic forms, valuation theory and model theory. Timeline of real algebra and real algebraic geometry. 1826 Fourier's algorithm for systems of linear inequalities. Rediscovered by Dines in 1919 and Motzkin in 1936. 1835 Sturm's theorem on real root counting. 1856 Hermite's theorem on real root counting. 1876 Harnack's curve theorem. 1888 Hilbert's theorem on ternary cortex. 1900 Hilbert's problems. 1902 Farkas lemma. 1914 Commersati showed that not every real algebraic surface is birational to RP2. 1916 Ferret's conjecture about non-negative trigonometric polynomials. 1927 Artin's solution of Hilbert's 17th problem. 1927 Kroll-Baer theorem. 1928 Pollier's theorem on positive polynomials on a simplex. 1929 Van der Waerden sketches a proof that real algebraic and semi-algebraic sets are triangularizable, but the necessary tools have not been developed to make the argument rigorous. 1931 Cauchy's real quantifier elimination, improved and popularized by Seidenberg in 1954. 1936 Seifert proved that every closed smooth submanifold of Rn with trivial normal bundle can be isotoped to a component of a non-singular real algebraic subset of Rn which is a complete intersection. 1940 Stone's representation theorem for partially ordered rings, improved by Caddison in 1951 and Dubois in 1967. Further improved by Poutenard in 1993 and Jacobi in 2001. 1952 Nash proved that every closed smooth manifold is diffeomorphic to a non-singular component of a real algebraic set. 1956 Peirce-Birkhoff conjecture formulated. 1964 Krivien's nullstellensatz and positiverstellensatz, rediscovered and popularized by Stengel in 1974. 1964 Lojejevich triangulated semi-analytic sets. 1964 Hironaka proved the resolution of singularity theorem. 1964 Whitney proved that every analytic variety admits a stratification satisfying the Whitney conditions. 1967 Motzkin finds a positive polynomial which is not a sum of squares of polynomials. 1973 Tognoli proved that every closed smooth manifold is diffeomorphic to a non-singular real algebraic set. 1975 Collins discovers cylindrical algebraic decomposition algorithm, which improves Tashi's real quantifier elimination and allows to implement it on a computer. 1973 Verdier proved that every subanalytic set admits a stratification with condition. 1979 Costa and Roy discovered the real spectrum of a commutative ring. 1980 Viro introduced the patchworking technique and used it to classify real algebraic curves of low degree. Later Ittenberg-Viro used it to produce counterexamples to the Ragsdale conjecture, and Mikarkin applied it to tropical geometry for curve counting. 1980 Akbalut and King gave a topological characterization of real algebraic sets with isolated singularities, and topologically characterized non-singular real algebraic sets. 1980 Akbalut and King proved that every knot in Sn is the link of a real algebraic set with isolated singularity in Rn plus 1. 1981 Akbalut and King proved that every compact place manifold is place homeomorphic to a real algebraic set. 1983 Akbalut and King introduced topological resolution towers as topological models of real algebraic sets. From this they obtained new topological invariants of real algebraic sets, and topologically characterized all three-dimensional algebraic sets. These invariants later generalized by Kuster-Kurdeiker and McCrory-Paruzinski. 1984 Broca's theorem on minimal generation of basic open semi-algebraic sets. 1984 Benedetti and Dado proved that not every closed smooth manifold is diffeomorphic to a totally algebraic non-singular real algebraic set. 1991 Akbalut and King proved that every closed smooth manifold is homeomorphic to a totally algebraic real algebraic set. 1991 Schmudgen's solution of the multidimensional moment problem for compact semi-algebraic sets and related strict positive Stellensatz. Algebraic proof found by Werman implies Resnick's version of Artin's theorem with uniform denominators. 1992 Akbalut and King proved ambient versions of the Nash-Tognoli theorem. Every closed smooth submanifold of Rn is isotopic to the non-singular points of a real algebraic subset of Rn, and they extended this result to immersed submanifolds of Rn. 1992 Benedetti and Marin proved that every compact closed smooth three-manifold M can be obtained from S3 by a sequence of blow-ups and downs along smooth centers, and that M is homeomorphic to a possibly singular affine real algebraic rational threefold. 1997 Bierstone and Millman proved a canonical resolution of singularities theorem. 1997 Mikarkin proved that every closed smooth N-manifold can be obtained from Sn by a sequence of topological blow-ups and downs. 1998 Koller showed that not every closed three-manifold is a projective real threefold which is birational to Rp3. 2000 Scheiderer's local global principle and related non-strict extension of Schmudgen's positive Stellensatz in dimensions 2. 2000 Koller proved that every closed smooth three-manifold is the real part of a compact complex manifold which can be obtained from CP3 by a sequence of real blow-ups and downs. 2003 Welchinger introduces an invariant for counting real rational curves. 2005 Akbalut and King showed that not every non-singular real algebraic subset of Rpn is smoothly isotopic to the real part of a non-singular complex algebraic subset of Cpn.